So it appears that genomes and living things, they're breaking down, as you've said, they're degrading and they're devolving, kind of like, rust on a car. And it seems to be, as you stated, the opposite of what that type of fish to fisherman evolution would need, because it's downhill.
Indeed. Think about it for just a moment. Everything is in a process of breaking down. So in genetics, this is simply the second law of thermodynamics applied to genetics. The same thing is true of stars exploding. Same thing is true of the rings around planets that are decaying very rapidly and will be destroyed within a matter of a few hundred years. But everything we see is decaying. Biological and natural systems all decay over time. And so things are not getting better. Again, mutations will never produce the kind of change that evolutionists would require. Again, you will never get an increase in intelligence or complexity by random chance. The only way in which you'll get an increase in intelligence or complexity is by the input from a greater intelligence.
And what's funny and amazing is that according to our worldview and the biblical based model, we would predict exactly that, right? Death, degeneration, extinction, things are going downhill.
Well, exactly. You see, the Bible tells us that God created everything perfect, whole, complete. But because of human sin, this brought decay into the universe. And of course, like a snowball going downhill, that decay gets worse and worse over time.
I like that analogy of the snowball. Actually, that makes me curious to ask you, do we know, because you said that, we transmit a small amount of mutations to our children, and so on and so forth, right? We're accumulating these mutations.
Today, each generation is adding approximately 60 mutations. So we have what's called genetic load.
Yes.
All these mistakes continue to accumulate over time. They never get corrected in any major way. Now, we have mutations going on in our cells all the time. There are mechanisms which God pre-programmed in our DNA. There are 7 little genetic engines that spend their entire day correcting the minor mistakes that are made every day, but they will not correct the major mistakes. They only correct the minor ones. And therefore, over time, we are accumulating. So Adam and Eve and the animals, plants, the universe was perfect. Human sin caused it to start a decay process. And initially, the decay process was, perhaps 1 mutation, 2 mutations per generation, but then you get 4. And since they don't get corrected, you add another 4, and now you've got 8. If you think about it, today, we are approximately the 250th generation since Adam and Eve. And that will vary slightly, but it's a pretty good number.
Right.
Now, the truth is we shouldn't exist. Think about that, 250 generations of accumulating all these errors in the genetic codes. We really ought not to be here. And it is only because of God in his foreknowledge pre-programming these 7 little engines in our DNA, which almost never break, some do, but almost never, that we are alive today.
Well, that's amazing. So it seems like, based on what you were saying earlier in regards to beneficial mutations, I know you pointed to sickle cell anemia. So it seems like the best beneficial mutations that the evolutionists can point to anyways, they're mostly reductive, right? You were talking about how sickle cell anemia, it's a significant impact, but it's a broken gene, broken protein. It's not taking things forward, right?
Correct. Now, think about it. Of course, in hospitals, evolutionists talk about superbugs, and
yes,
and I take this very personally. My own mother died from one of these conditions. Now, they call them superbugs because our antibiotics can't kill them, and eventually they overwhelm us and kill us. Correct?
Correct.
By calling them superbugs, the evolutionist is using a spin machine. This is propaganda. This is Goebbels. They make people think that the bacteria got bigger, better, faster, smarter, that the bacteria invented some new mechanism to prevent an antibiotic from killing it. That's not what happened. What happened is the reason that these so-called superbugs survived is because they became defective. You see, if we have a bacterium, and let us say that there are 100 different ways we could attack it and kill it. So we can come up with some antibiotic that locks up a receptor on the outside cell wall, or it locks up a port by which elements are moved, or we lock up an enzyme inside the bacterium, and that causes the bacteria to die, or it can't reproduce, or something. What we're actually doing today is we get an antibiotic, and it fits the cell receptor. But what happens is, and since we're in video, I'm going to try to just do a little analogy here. Let us say there's a cell receptor on the wall, the outside wall, and we get an antibiotic, and the antibiotic is like a key, and the cell receptor is like a lock. And so we get the key, and it fits the lock, and it keeps the cell receptor from working, so the bacteria dies from malnutrition. What happens that gives immunity to the bacteria is it doesn't develop a bigger, better, faster, smarter cell receptor. What happens is there's a mutation that causes a deformation of the cell receptor. Now our lock won't fit into the key. Therefore, we can't kill the bacteria. Now, what we're doing experimentally, you might say, is over time, by developing this antibiotic and then that antibiotic and then this antibiotic, we're actually finding out how simple a bacteria can be and still survive, because as we knock out each of these points, a mutation causes this deformation so that our keys no longer fit. And so what happens is we start with a bacteria that has 100 points that we could attack, and we attack one, but it becomes deformed. Now, the bacteria is defective. It metabolizes slower, it reproduces slower than the natural non-defective bacteria, but we can't kill it. And so we attack number 99. Then we get a bacteria where our antibiotic will kill the bacteria using that 99, but then there's a mutation that causes a corruption, a loss of the previously existing perfect information. And what happens? We can no longer kill it. So now we go to 98, and we are knocking out one at a time these points at which we can kill the bacteria. And what we're really finding out is how simple the bacteria can be and still survive at all. The problem is we can't kill it. So it's metabolizing slower, it's reproducing slower. If we put it in a culture, take a petri dish, put it in a culture with a natural bacteria of the same kind that does not have these mutations, the non-defective bacteria will overwhelm the defective bacteria and eliminate them. And so these are not super bugs, these are defective bugs.
Wow, there's so many good points in there. So it looks like bacteria, these adaptations and changes that are being seen, they're all due to degenerative.
Yeah, they're not adaptations. They are defective. And so instead of the progressive mechanism that evolutionists believe in religiously, what we really see is a regressive thing occurring in nature.
So things can change, and I guess the benefit is only as good as the environment, because overall what you're saying is it's deleterious.
Well, mutations are deleterious over time.
Right.
And again, they continue to mount up, they continue to pile up, so that the pile is not only getting bigger and bigger, but it's getting bigger and bigger at a faster rate. So that what is happening is we have what, as you said earlier, we have genetic entropy. The ultimate conclusion of that is that human beings could not even have existed for 100,000 years, much less 500,000, 1 million, 4 million, because we would already have gone into what is called genetic catastrophic failure, where what happens is we become sterile, can no longer reproduce, and that causes extinction. And I think you will agree that extinction is about as harmful as it gets.
Yes.